All right, Finite Math class, this is a walkthrough of the first half of the first packet that I gave you, talking about basic set concepts. So we're just going to go through the first half. A set is a collection of objects whose contents can be clearly determined. So here's an example of set A. Set A has the elements of 1, 2, and 3. The elements are the objects in the set. So here's set A with 1, 2, and 3. The elements 1, 2, and 3. There are 3 ways to designate a set. One is word description. Second way is roster method. Third way is set builder notation. Word description is just as it sounds. It's a word description of the sets of the elements that are in a set. So S is the set of states who begin with the letter A. Roster method is like you would list out the elements that fit the description of the words. So here, Alabama, Arkansas, Alaska, and Arizona are the states that begin with A. Set builder notation is kind of like a combination of the first two. The main thing is you have this X with a long bar, and then X is a U.S. state that begins with A. So notice it has S equal to, and it's very similar. It starts off the same way that the roster method starts off, and then it gives you a description of it on the inside of your braces. This circle is not here for set builder notation. Normally, I just circle that in the notes just to signify that that's the main thing you have to remember to put in there. So here we have A is the set that has X as a month that begins with M. This is an example of set builder notation. Like I said, the circle is not here normally. And so if we were to list that using the roster method, that would just be March and May. The month that begins with the letter M, March and May. Empty set, also called the null set. Empty set and null set are interchangeable. They expect you to know that both of them mean the exact same thing. It's a set that contains no elements. It can be represented by either your braces with nothing in it or a circle with a slash going through it. So which one of the following represents the empty set? So the first one, the braces with 0 in there, is not the empty set. Remember, it has to be the braces with nothing in it. Of course, the number 0 is not the empty set. Here, we have set builder notation. X is a number less than 4 or greater than 10. I should have made this more clear. This is no. You know, if we had the notes on the board, I would be able to erase and do different things. But the answer is no. The reason being is because of or. It's possible to be less than 4 or greater than 10. Now, if that or was an and, then it's impossible to be less than 4 and greater than 10. So this section, this chapter is going to force you to pay attention to words and specific words, because that will dictate whether your answer is right or wrong, whether the answer is yes or no, true or false. So the fact that it says or, it is possible to be less than 4 or greater than 10. You cannot be less than 4 and greater than 10. So there are plenty of numbers, infinite amount of numbers that fit this description. So D would actually be, yes, that would be the empty set, because there's no such thing as a square with exactly 3 sides. So there's no shape that fits that description, being a square and having exactly 3 sides. So that would be null set. Greek letter epsilon. Epsilon represents is an element of. When you throw a slash on it, that is not an element of. So this statement right here, 5 is an element of the set 1, 3, 5, 7, and we see 5 here, so that's true. If you look at just this statement right here, this is 5 is an element of set A. So epsilon represents is an element of. So determine whether it's true or false. Here you have A, B, C, dot, dot, dot. That's your ellipses. And it just means to continue on with that pattern all the way to Z. So R is an element of this set. That is true. Here, this is a slash through the epsilon. So 7 is not an element of this set, which once again is true. Now here, this one, C is false, because you have your braces with the set representing just having A in it. Is an element of the set having A and B. So this is false. In order for it to be true, it had to read in one of these 2 ways. So that's why this is false. Natural numbers, just a set of numbers that begin with 1 going on to positive infinity, no decimals, no fractions. We will use that to that will be represented by capital N going forward. So if you had to express using the roster method, set A is a set of natural numbers less than 5. So remember, you can't go past 1. So that just would be 1, 2, 3, and 4. Set B is a set of natural numbers greater than or equal to 25. So since it says or equal to, you start off with 25 and you go up to positive infinity. Use at least 3 numbers to set your pattern, and then you can use your ellipses. Then here, this represents X is the natural number, or is in the set of natural numbers, and X is even. So you're just talking about 2, 4, 6, 8 on the positive infinity. So then we're looking at our inequality symbols. Less than with a bar under it is less than or equal to. Greater than with a bar under it is greater than or equal to. So we're getting to the point where we're using less and less words and more symbols. So here, X is a natural number and is less than or equal to 100. So you go from 1 to 100. Set your pattern at 1, 2, and 3. Use your ellipses, your 3 dots, and go to 100. Next one, X is a natural number. Then it says X is greater than or equal to 70, but less than 100. So since it's or equal to, we start with 70, and then it's less than 100, so we just go up to 99. Cardinal number is the number of distinct elements in a set. So we look at N of A, in parentheses A, that's the number of elements in set A. That's what that represents. So the lowercase n represents the number of elements in set A. So notice here we have set A is 357, set B is 3555777. Remember, your cardinal number is the number of distinct elements. So it would be 3. The cardinal number would be 3 for both sets. Distinct elements. So even no matter how many times it's repeated, talking about distinct elements. So that's why both of them are 3. So for A, the cardinal number would be 4. We just have 4 elements here. 0 is an element. So for B, the cardinal number would be 1. For C, you would just count all of these out. And you would have 11 numbers. So your cardinal number would be 11. Then for D, we have the null set. So the cardinal number of the null set is 0. You don't have any elements in the null set or the empty set. Equivalent sets. Set A is equivalent to set B if they contain the same number of elements. So that means the cardinal number is the same for both. So we have the 2 examples. X is a vowel, or X is a natural number and between 3 and 7 inclusive. A, E, I, O, U, 5 elements. 3, 4, 5, 6, 7, 5 elements. So that means set A and set B are equivalent. Equality of sets. Set A is equal to set B if both sets contain exactly the same elements, regardless of order or possible repetition. So A is equal to B if the elements are the same. So this is just an example of that. W, X, Y, Z, Z, Y, W, X. All right, section 2, subsets. Set A is a subset of set B if every element in set A is also in set B. And this will be a symbol that we use for a subset. So this is a symbol subset with a slash through it. It's not a subset. So we have A 1, 3, 5, 7. B is 1, 3, 5, 7, 8, 9, 10. So A is a subset of B. A for this one is a letter in the word proof. A is a letter in the word roof. That's P-R-O-F for A, R-O-F for B. So A is not a subset of B because B doesn't have the letter P in it. So remember, all the elements in the first set has to be in the second set in order for it to be a subset of. So in order for A to be a subset of B, all the elements in A has to be in B as well. So proper subset. Set A is a proper subset of set B. If first, it has to be a subset. and then A is not equal to B. So A does not have to have all the same elements in B. So once again, to be a proper subset, you have to be a subset first, and then A has to not be equal to B. And so the symbol here is very similar to a subset, but without the bar under it. All right. So here, for the first example, we want to write subset or proper subset. X is a person and lives in San Francisco. X is a person that lives in California. So if we look at California and compare it to San Francisco and vice versa, San Francisco is inside of California. So San Francisco is not equal to California. San Francisco is inside of California. So that means A is a proper subset of B. Then we look at the second one. We have 2, 4, 6, 8, 6, 8, 2, 4. A and B are equal. So A is a subset of B, but A is not a proper subset of B. Remember, if it's equal, it is not proper. So A is a subset of B, but A is not a proper subset of B. All right, another example. We have the natural numbers that are between 5 and 12, so it's 6 through 11. Then natural numbers between 5 and 12. Just worded. So A, once again, since they're equal, A is not a proper subset of B. Now here, we have the same thing that we have in the previous example that gives us 6 through 11. But then we have 2 through 11 inclusive. So this would mean that A is a proper subset of B. 6, 7, 8, 9, 10, and 11 are in the set B, because that one starts at 2 and goes to 11. So A is a proper subset of B. All the elements of A are in B, and they are not equal. Sets A and B are not equal. All right. So empty set as a subset for any set B, the empty set is going to be a proper subset and a subset of B. The way we'll calculate the number of subsets, you take n, which is going to represent the number of elements, and put it to the power, allowing 2 being your base. So we have 2 to the n power, and then the number of proper subsets would be 2 to the n power minus 1. So here's an example of that. If we're looking at a set that has A, B, and C in it, that means n is equal to 3. We have 3 elements. So subsets would be 2 to the 3rd power, which is 8. Then proper subsets, 2 to the 3rd power minus 1, which is 7. So over here, just showing you all of the subsets that can be created out of A, B, C. Notice we have BAC, B, A, C individually, BA, AC, BC, and the empty set. Remember, we just saw in the previous slide that the empty set is also going to be a proper subset and a subset. So those are all of the subsets. Notice we have 8 of them here, and that's how many subsets we have. The minus 1 comes from here. The one that's equal to the original set would not be a proper subset, so that's why you subtract 1. So these would be your 7 proper subsets. All right, last slide. So here we have 5 elements. So n is 5, 2 to the 5th power is 32. That's the number of subsets. Subtract 1 from that, that would be the number of proper subsets, 31. Then here we have natural number, x is a natural number. And we have all the numbers between 9 and 15 inclusive. So that's 9 through 15, that's 7 elements. So 2 to the 7th power is 128, so it's 128 subsets. And then the number of proper subsets, we subtract 1, we'll have 127. So that's the first half of that packet, that first packet that I gave, chapter 2.